This begins our lesson on our 20.1 in our note pack. Note packs are open to page 4. Page 4, you'll see a title that says Describing Acids and Bases. We are going to just kind of describe the journey, talk about what makes acids a special kind of category of chemical families, and describe the opposite characteristic of those of bases. So on page 4 of our note pack, Describing Acids and Bases, you've already completed a reading guide that did a nice job in previewing some of those topics that we're going to catch up on now in terms of our note pack. So looking at our presentation on properties of acids and bases, we're being asked to just describe some of those common properties that make acids a unique chemical family. Well, acids, of course, as we had written in our reading guide, they have a taste sour or tart, such as thinking vinegar or lemons, coming from something called citric acid. We do know that they cause indicators to change colors. Indicators are often used during an acid-base neutralization. A common indicator that we will use and have used is called phenolphthalein. Now that's quite a tricky word to spell out. Phenolphthalein is clear in an acid and pink in a base. Acids have pH readings below 7, and again the pH scale, much more to come on the pH scale, but we'll understand that 7.00 is exactly a neutral solution, and as the pH begins to climb down and become a lower and lower number, all the way down to pH of technically 0, the solution becomes more and more acidic. So things in common about acids: they taste sour or tart, they cause indicators to change color, they neutralize a base through a process called neutralization. It's nothing more than a double displacement reaction where water is the driving force, and they all have pH readings below 7.00. Considering properties of bases, well, bases, of course, are the opposite of acids. They're going to neutralize an acid. Just thinking about that in terms of some double displacement. Here is a familiar acid called hydrochloric with a familiar base, sodium hydroxide. Acids, we know, always start with H. Bases always end with OH. And I think about this word neutralize, the driving force here is nothing more than an old double displacement, a very familiar pattern to us, where HOH, commonly written as water, and NaCl are our products of this acid-base neutralization. When an acid neutralizes a base, it will create what's called a salt, sodium chloride, and a water. Bases tend to taste bitter, they feel slippery like soap, they cause indicators to change color, and these guys, they're going to have pH readings greater than 7. Again, if 7.00 is the point of being neutral, 7.00 is exactly when the acid ion equals the base ion. When H plus and OH negative are exactly equal, we have a pH of 7. If we have more hydrogen ion, the solution is acidic with low pHs. If we have more hydroxide ion, the solution is basic, where we have pH readings above 7. Kind of previewing a next lesson on pH calculations. Turn your page in the note pack. We're going to review nomenclature rules for naming acids and bases. This is a completely review topic, but it doesn't hurt to review as we're getting ready to our final exam anyway. Our very definition of an acid says acids, oh, I'm sorry, we didn't turn our note pack page yet, but acids are substances that release hydrogen ions when dissolved in water. Couple of key things here: acids and bases always are in water solutions. If we consider any general formula, acids always start with H, like HCl. HCl, when placed into water, creates ions. It creates a hydrogen ion and a chloride ion. Ions are always aqueous, and outside of water, hydrogen chloride is actually a gas. So if we bubble hydrogen chloride into water, we create aqueous ions. This right here is the very definition of an acid, something that when dissolved in water releases hydrogen ions. This is what we track when we measure something called the pH, the power of the hydrogen ion. The pH is just a numbering scale telling us how acidic or how basic a solution is. So any acid with a general formula HA, where A might be any negative anion, when dissolved in water and releases hydrogens, it is said to be an acid. We're going to practice naming acids right now. Rules for naming acids focus on the name of the negative ion. Rules for naming acids focus on the negative ion. Now this we once talked about way back in the beginning of our course when we talked about it's the negative ion that determines how we go about what set of rules we're going to look at following. So I'm just trying to get my notepad adjusted. Now I'm looking here in the notepad page, top of page 5, and these are the 3 rules for naming acids, and they focus on the negative ion, and we have a little grid we can fill in together just to kind of remind ourselves what those rules are. So I think what I'll do is leave this PowerPoint slide aside and just focus so we're looking at the same area here. If the original ending on the negative ion was "ide," I-D-E, as in chloride, the rule says to name that as hydro, root word, ic. If HCl is the name of an acid, it would have been named hydrogen chloride, but now we name it hydro, root word, ic. We'll write hydrochloric acid. If the original ending has some oxygen on it, and the oxygen from that polyatomic ion chart, we know those to end with "ite" or "ate. If, for example, we have an acid that originally would have been hydrogen sulfite, I would have originally called this hydrogen sulfite, but now to name it as an acid, we take that stem or that root word, change the "ite" to an "us, and now naming it as an acid, we come up with sulfurous acid. And the last rule says, what if it ended with "ate"? We would have named this guy as an acid here, nitrate. I didn't write that in. Let me jot that down with you in your notes. We had chloride, hydrochloric. Sulfite becomes sulfurous. Nitrate becomes nitric acid. Completely review, but worth mentioning again as we're getting more and more comfortable with our nomenclature rules. Ide, hydro, root word, ic. Ite becomes us, ate becomes ic. Notice, friends, just to remind ourselves, the only time I hear anything about the hydrogen is when that original ending came from "ide." Otherwise, we don't hear about it. We don't need to hear about it because we know acids always start with hydrogen. What about bases? Bases, of course, are opposites of acids. Completely different chemical properties, completely different ends of the spectrum on the pH scale. We'll define a base in our notepad as any substance that releases hydroxide. And remember, that's our polyatomic ion OH, and it carries a -1 charge. Hydroxide ions are released when we place them into water. They have a general formula of some metal ion hooked to the negative polyatomic hydroxide. And just remember, consider charges when you're writing formulas for bases. When we're naming bases, we simply just say the name of the compound, the metal, followed by the word hydroxide. Now it says, for example, sodium, who's a +1, hydroxide, who's a -1. We're just going to say the name, sodium hydroxide. What if our metal ion carried a +2 charge? Remember the crisscross rules, in a parenthesis, MgOH taken twice, and we just simply say the name of the compound, no special set of rules at all for bases, magnesium hydroxide. When these are placed into water, They release ions. Ions are always aqueous. Ions carry charges. Now, sodium hydroxide is actually just a white pellet. It's a solid particle. We've used it before in the lab. So when I take it off the shelf, it's a white solid. When I dissolve it into water, this ion, along with sodium, but this ion, when it's being released, this is something that we can track and measure the pH of our solution. So the concentration of the base ion through a calculation we'll learn a little later on in our unit can be converted to pH. And just to show this guy as well, magnesium ion, and again this starts as a solid, we place it into water and it dissociates. Notice that we would get one magnesium ion, but we would release two hydroxide ions, that 1:2 ratio. And this right here is what we measure on a pH scale. If we have more base ion in solution, hydroxide, as compared to hydrogen, we then now know that our pH is above 7 on our alkalinity pH scale. Bases release hydroxide. No special set of rules for naming bases. We just simply go by the original name, metal ion with hydroxide. We're going to just practice our nomenclature. We're being asked to name these as acids. Well, we can see they all start with H. Knowing that they start with H says we now know they're acids. And it all goes by the polyatomic ion ClO -1, Cn -1, PO4 -3. Name the polyatomic ion and we can find the set of rules for naming the acid. ClO -1. On your polyatomic ion chart, which I don't know if I have one nearby, on the polyatomic ion chart, look at yours. First column, I'm going to say most of the way down, 3/4 or better of the way down, you're going to see the polyatomic ion ClO negative. It's called hypochlorite. All one word, hypochlorite. Important thing to see is that it's an ite ending. Ite ending says ite turns to us and we simply put on an OUS ending. Hypochlorite, named as an acid, becomes hypochlorous acid. Hypochlorous acid, HClO. Name the polyatomic Cn -1. Now this is in the first column, about halfway down of your polyatomic chart. We know this to be named cyanide. Cn -1, it's polyatomic name cyanide. The IDE ending, ide. Hydro root word ic. Hydro root word ic becomes hydrocyanic acid. PO4, I know it's -3 because when I crisscrossed I see 3 hydrogens there. Phosphate is the name of our polyatomic ion. Notice the ending, ATE. To remind ourselves, 8 turns to ic, and we get, some people say phosphic, but it just sounds better, I hope, at this point in our journey of chemistry, phosphoric acid, H3PO4, phosphoric acid. We named hypochlorous, hydrocyanic, forgot my C, and phosphoric acid. We have a series of practices in our note pack. Pause the video, pause it, get out your periodic table polyatomic if you haven't yet, and I want you to work these through. When you have listed your answers, turn the video back on and check your work. Pause the video, work ahead, turn it back on when you're ready to check. All right, let's check our work. HF, we would have named this hydrogen fluoride, IDE, hydrogen fluoride. Now we know to name it hydroperoxide hydrofluoric acid. Fluoride, hydrofluoric acid. Polyatomic ion here in letter B, you looked up and found nitrate, A-T-E, nitrate. 8 turns to ic. Did you write nitric acid? These both, by the way, started with H. I know they're acids. Those elements, or those compounds that start with H, we know to be acids. Sometimes, if I'm just kind of thinking through ahead of the game here, if they end with OH, we know them to be bases. Letter C will be named a base. Here's a base, and here's a base. It's kind of thinking ahead of what's an acid, what's a base. Starts with an H, it's an acid. Ends with an OH, it's a base. And we said there's no real special rules for naming bases. We're just going to say their name. Say the name of the element K. We know that to stand for potassium. Here's the polyatomic ion, hydroxide. Letter D, polyatomic ion here came from sulfate. Sulfate ends with 8. 8 turns to ic, and we simply name this sulfuric acid. Letter E, checking your work for me. CO3 minus 2 is a polyatomic ion. You found the name carbonate. 8, carbonate. We call this carbonic acid. Soda pop acid gives it its fizz. Polyatomic ion, ClO3, carries a -1. Find it on your chart. You found chlorate. Here the 8, chlorate. 8 turns to ic, and this is simply called chloric acid. Letter G, this is a base. Say the name of the metal ion and the last name hydroxide. This is called aluminum hydroxide. And letter H, same idea, saying the name of the element Ba stands for barium. The polyatomic base ion called hydroxide, barium hydroxide. Acids have a special set of rules based on the last negative ion, the last name that they're hooked to. And we know to follow our guided chart. You might have even written that somewhere helpful a long time ago in the beginning of Chemistry Land. Following the an ion ending, we learned how to change it into the name of an acid. What if we're asked to go the opposite direction in the next series of examples? We're being asked to name these as an acid or a base. So if it's an acid, we see the name, turn it into a formula. If it's a base, turn that name into a formula. Again, with the help of your periodic table and polyatomic chart, pause the video here. Please pause the video, work ahead, and then come back and check your answers. That practice really does help to deepen your learning. Pause, and when ready, start it up again. All right, you must be ready to check your work. Letter A reads chromic acid. Right away, if it says acid, I know the first name to be H, and we know that hydrogen carries a +1. Ic. There's no hydro, and I just see ic. Ic came from 8. We look up the polyatomic ion called chromate. Chromate. Middle column, almost to the end of the row there, we find chromate. CrO4 -2. Crisscross, H2CrO4, chromic acid. Letter B, iron, Roman numeral 2, hydroxide. This is a base. Iron, Roman numeral 2, tells me the charge, not how many you have, but the charge. Iron, Roman numeral 2, hydroxide. You wrote that, I bet, as FeOH taken twice. Hydroiodic acid. Hydroiodic acid. Well, I know acids start with H. The very definition is hydrogen will be its first name. Now I'm seeing hydro root word ic, so I know that the original ending must have been "ide." We are going to look up the compound called iodide, right on your periodic table. Now iodide, look at the 7th column, group 7th A, fluoride, chloride, bromide, iodide. It's simply HI, hydroiodic acid, HI. Letter D, last name is the base name, hydroxide. Lithium with its +1, hydroxide with its -1. LiOH is the base called lithium hydroxide. Barium hydroxide. We know barium to carry a +2, so when we crisscross in a parenthesis, taking 2 groups, we get BaOH taken twice. Letter F, hydro root word ic acid, hydrobromic acid. Acids start with an H, hydrobromic. I know that hydro root word ic must have come from the original ending "ide." We need to find bromide. Now look at the same column as a moment ago, iodide. We looked at the 7th family, fluoride, chloride, bromide, iodide, hydrobromic acid, HBr. Rubidium hydroxide. Rubidium, first column carries a +1. Hydroxide, our base ion, RbOH, rubidium hydroxide. And the last one you're checking, hydroselenic acid. Acids start with an H, hydroselenic. Hydro root word ic. We're looking up an element that originally would have been selenide. Selenic acid, hydroselenic, came from selenide. Find oxygen's column. Oxide, sulfide, selenide. See the symbol there? Under oxygen is sulfur. Under sulfur is selenium. When named as an ion, it becomes selenide. Its formula is Se. Carries a -2 charge in that column of oxygen's family. H2Se, hydroselenic acid. At this point, you've completed your Moodle lesson on properties of acids and bases and a review of the nomenclature, those rules for naming acids and bases. You are now ready to complete the assignment page, the practice page on naming acids and bases.